looking at the exponential functions today, and we're going to try to just graph some basic ones where the base is some positive number greater than 1. Now we're going to look at values that are less than 1 and greater than 0 still. So let's begin with I guess something probably the most basic, just a simple function 2 to the exponent x. And I have a table of values here where I'm just calculating the value for each x. The first one's there done for you. The second one is going to be 2 to the negative 2, which is just 1 over 4, or 0.25. 2 to the negative 1 is going to be 0.5. 2 to the 0, anything to the exponent 0 is 1. Anything to the exponent 1 is itself, whatever the base is. 2 squared is 4. 2 cubed is going to be 8. So there's our table. If we want to now graph this and take a look at it kind of globally, let's start plotting these points. So the first one is extremely close to the x-axis. That's kind of hard to draw, but we'll do our best. So negative 3 will be somewhere around here. With negative 2, we're a quarter of the way above the x-axis. And then for negative 1, we're halfway. And then we're at number 1 on the y-axis. And then when we get into a base of 2, 1, we're 2 above. So that's, oops, I think I should actually, we're going up by 2's, so 2 to the exponent 1 is 2, and then I have 2 to the exponent 2, which is 4, and then 2 to the exponent 3, which is 8. And if I connect all these points together, I get something like this. And that continues going, so I'm going to put an arrow on that end, and also on this end here. So an exponential function, we say it's increasing. As you can see it, as it goes from left to right, it gets bigger and bigger. What happens if we were to change the base to something like f of x equals 3x, or 4x, or 5x? Okay, let's take a look at that on Desmos. So I'm going to open this up, clean this up here, and let's enter in a function. I'm going to have f of x, put brackets there, equals, and I'll have a varying base, so I think we had m there, to the exponent, and we'll put an x over there, and we're going to change the value of m. So we had in our question here, we had m equals 2, so that's, do that there, that's our graph, so one we just did by hand. I'm trying to get that exactly. And let's kind of zoom into the area where it's interesting. There's our 0, 1. When x was 2, we had a value of 4, as you can see over there. When x was 3, we had a value of 8, as you can see, kind of up here. And it's very close. I don't think I can get it right on, but you get there it is. And as we go for negative values, we get closer and closer to the x-axis, but never touching it, so it is an asymptote. But what happens, like I said, when m is a value of 3? Well, let's increase that. You can see the graph just gets kind of pulled up more. And if it's bigger, let's say 5, it gets pulled up even more. And the bigger we go, and here we only have going up to 10, we can see that the value of, so the shape of the graph gets narrower and narrower. And the bottom here kind of gets tighter and tighter. Okay, it becomes a tighter corner, whereas, as I go closer to 0, becomes a smoother kind of transition, whereas as I get bigger and bigger, it gets tighter and tighter, and it goes up faster and faster. So if I could, if I wanted to, I could increase this to, let's say, 100. We're not going to go below 1, so I'll just put 1 there and go up by 1s. Let's see what that looks like in graphical terms. Kind of dynamically, you can see it gets, again, pulled more and more and more. Okay, as it gets closer to 1, a flat line there, and then we go back to that pull. So that is what our graph looks like. F of x equals, some positive base greater than 1 to the exponent x.